So here we go. We are using the sum and difference identities to solve. So we know we better use our chart over here at some point for this problem. Okay, this is a problem you just got to recognize what's going on. Okay, it says given a lot of different information here. It says given cosine alpha is that, and alpha is between pi and 3 pi over 2. Okay, and then this and that. They gave us a lot of information. Notice that they talked about alpha and they talked about beta. So hopefully that sets off a reminder in your brain that you need to set up two separate triangles. You need to set up an alpha triangle with x, y, and r. And you're going to set up a beta triangle with the same stuff. Questions so far? Now we're looking at this information. It tells us that cosine of alpha is negative 3/4. So Haley, what's that telling me here? Good. X is negative 3. R is 4. She already knew that her x was the negative thing and not the r because it can't be. A lot of students next would say that my y is 5, but that's not true here. Okay, think about what we're talking about. This is a triangle. Okay? This is my radius, also known as my hypotenuse. Okay, if my r is 4, why is my y not 5? This has to be the biggest side. The radius has to be the biggest side. And if I've said my y was 5, that would not be true. All right, so this is kind of goes against what the simple shortcut we've done every time. But we're not sure here. We're going to do Pythagorean theorem. X is 3. I don't know my y. And my radius is 4. So 9 plus y squared equals 16. So y squared equals 7. So what's my y going to be? I'm square rooting. So just square root of 7. Just square root of 7. What type of problems? Just be careful. Okay, that happens very rarely, but just make sure that if you're using those special right triangles, that the biggest number there better be corresponding with your radius. Okay, the biggest number, so like the other one is 5, 12, and 13. Okay, that means the radius has to be 13. It can't be the other way. Just be careful. Okay, so we did this. Great, we used that bit of information. Now we need to use this. It says that alpha is between pi and 3 pi over 2. Okay, so go to your unit circle and put your finger on pi, and then put your finger on 3 pi over 2. So, Jocelyn, here's pi, and here's 3 pi over 2. What's true about the ordered pairs between those two things? X and y are both negative. Good. X and y are both negative. So when I'm up here, my x is already negative. Haley already told me that, but I also know that my y is negative because of which quadrant I'm in. Good. Did that. Now let's jump to the second one. The second one's a little bit easier. Tangent of beta equals negative 4/3. So tangent is y over x. So Deontay, what's that tell me? Y is 4, x is 3. Now this would help us. This would make sense. If that one's 3 and that one's 4, what's my radius going to be? Now it's 5. Yep. And that makes sense here. Okay, I know that one of them needs to be negative because tangent's negative, but I don't really know which one. Okay, that would help me by looking at that. My beta is between negative pi over 2 and 0. Okay, so put your finger on negative pi over 2 and your other finger on 0. Where's negative pi over 2 up there? Yeah, 3 pi over 2. Yeah, down here on the bottom. This is negative pi over 2 right here. And this is 0. So, Jalen, what's true about the ordered pairs between negative pi over 2 and 0? X is positive and y is negative. So up here, I'm going to make my y negative. I'm in quadrant 4. Okay, just double check yourself with that. Not a hard thing. Don't forget it. That's the hardest part about this problem, setting up our triangles. Once we've set those up, now all we're going to do is write down the formula. It says find cosine alpha minus beta. So I'm looking at those sum and difference identities. Remember, they are on the back of your unit circle that we passed out, so you can look there, or they're up here on the wall. Right here it says cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. You've got the setup. Plug in what you know and solve it now. Okay, I don't think a whole lot of us have solved it yet. Go ahead and solve that without me. We've done the hard work here. Cosine alpha, I'm just looking at my alpha triangle, and it's x over r, so negative 3/4. Cosine of beta, so looking at beta, x over r, so 3/5. Plus sine of alpha, so alpha sine is y over r, so negative radical 7 all over 4 times sine of beta, so beta y over r. When you set it up, notice that your denominator should be the same. On both sides, I have a 4 and a 5. A 4 and a 5. Okay, that better be true, or otherwise you made a mistake. Now we're just multiplying fractions. Okay, so Aridiana, what's this first fraction going to look like when I multiply? Negative 9 over 20. She just multiplied straight across. Boom, 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 boom. Plus that second one. The thing I always want to look at first is how many negative signs do I have? 2. 2 in the second part. So is it going to be a positive sign in between or a minus sign? Positive. 2 minus signs get you positive again. So this is plus. I'm taking 4 times radical 7. What's 4 times radical 7? 4 radical 7. Again, treat it like an x. What's 4 times x? 4x. 4 times radical 7 is 4 radical 7s. On bottom, it's 4 times 5. So I have 20. Finally, I can add the fractions. Negative 9 plus 4 radical 7s. Yeah, again, it's like negative 9 plus 4x. I wouldn't combine those together. I don't combine this together. Negative 9 plus 4 radical 7s. And on bottom, I've got 20 plus 20. Still 20. Don't change it. Common denominators for a reason.